Alright gang, sorry for the abrupt ending of the other video. I probably shouldn't even tell you what happened, but I really don't care. This computer that I'm working is primarily used by my wife, and she has her messages that pop up on this computer when she gets a message. And someone sent a very kind of a racy political cartoon. I don't think it's that bad because I don't get worked up over that stuff, but I know how worked up people get about politics these days. So in case you are of the political party that would have been offended by that, I abruptly cut off the video so you won't see that. Personally, I think it was pretty funny, but again, people get so bent out of shape about that stuff these days that I'm playing it safe. All right, guys, enough of that. So you've got all the questions answered for the project. Now what do you do with it? Well, you type it up in a kind of a comprehensive document. So your final project is going to look something like, almost identical to this. So you would say the variables. This project are, so for mine it was age and stay. The sample size is in equal, and what did we figure out there? Sample size was 99. And 99 patients. The distribution shapes. Now here you've got to go create histograms of both of these and see what they look like. So I'm going to do a histogram of both of these because I can. Alright, so that's bell-shaped and symmetric, and that is also bell-shaped and symmetric. If you called that positively skewed, I'd let you get away with it. So this is stay and this is age. Well, let's call that positively skewed because that's probably more what it is. So I'm just going to say that. The distribution shape for age is bell-shaped and symmetric. And for stay is positively skewed. The descriptive statistics are, and guys, what you want to do here is you want to insert a table. And our table needs to be a, 3 by 5? So I have age, and I have stay. So I have the mean, the median, the standard deviation, and the IQR. So guys, I'm just going to type in, so 52.96, 9.57. The median is 52.80, 9.35, sorry for the redundancy, 4.26, 1.74, IQR is 5.40, and 2.13. All right, cool. Next thing we'd want to do is we'd want to check for outliers. So I'm going to do a box plot for each one of these to see if there's any outliers. So go to Graph, Box Plot, each one, and do draw boxes. Okay, use fences to identify outliers. So you need to make sure that box is clicked or you won't get the outliers. So there are a couple of outliers. There are 2 outliers for age, and there's 1 outlier for stay. Actually, there were two outliers. All right. Actually, that shouldn't be indented because it's still part of the first. All right. The next thing I'd want you to do is talk about the regression coefficient, R and R squared. So what you would do there, you would say that a correlation and regression analysis was conducted for x equal age and y equals stay. The scatter plot indicates a linear relationship. What's going on there? That's not true. Indicates a linear relationship between age and stay. I'm sorry, indicates that the linear relationship between age and stay is weak and positive. So what you would do here, you would come in with the R value, and I found the R value to be 0.15. And then R, and guys, to make the R squared, I can go right up here and put the squared, then click it again, it gets out of it. So the R squared is always given as a percentage. All right? The coefficients for the model are 0.060, that's the slope, and 6.41. Because I promise you I can spell, I just can't type. For the intercept. All right, so that's done. The final thing you're going to do is you're going to talk about the results for the test of significance. So in testing the claim that the average stay is 12 days, and again, this is for my hypothetical, just to give you an indication of that, this is for this hypothetical data set and set of questions. Okay, so but your questions are going to look very similar to that. So let me get what we need. So when testing the claim that the average stay is 12 days, the results were statistically significant. And here's where you put in the fancy stuff. So the degrees of freedom equal negative 13.90, p less than 0.0001. Then you would say the 95% confidence interval, which we did the week before, is 9.23, comma 9.92. Guys, that's it. That's all you need. Just like that. And what I'll do is I'll upload this to Blackboard. If I can, I'll have to see if I can set up another folder. I'll have to see. If not, I will email this to you. So, guys, that's what's up. That's the way we do this. So, guys, what you do here is just save it. And save as. I would do just a final project. STAT1150. Your name. My name's Doug Darborough, so I would do that. I would save it. And then you can either email it to me. Well, no. I need you to post it to Blackboard. So it'll be graded. So guys, that's what you do for the final part of the final project. I wish I could show you the political cartoon, but I'm afraid you guys will get all bent out of shape over it. But anyway, so accept my apologies for the abrupt ending to the previous video. Hope you're having a great semester. I guess that's all I got. Take care.